if the value of current measured by AC ammeter. So what current this is? This is the total current. We have total applied voltage. This current should be independent of R. Means that's why it's telling the arrow. So as you move this, they should not show any deflection. Means like the deflection here should not change. There should not be any deflection. How things are possible? So we know we have did several problems now. At the very R, this impedance will change. Definitely the reactance here XC plus. So what is the impedance? That one you call it. Here it's a reactance. So definitely what when the effective impedance will change. Yes, it's asking as you vary this, there should not be any effect of impedance on the total impedance of circuit. What do you mean by impedance? Resistance plus reactance. Okay, let's take the source voltage as reference. So here, there's the source voltage. Let me write Vs. And let the current be I. We know in across inductor or this current, let it be IL. Across the inductor, the same, because they are in parallel, across inductor current will lead or lag the applied voltage. Very basic things. If you forget, inductor should be lag, no? Current should lag. Okay, lag means by what angle? By 90 degree. So therefore that is IL. Now what is RC circuit? Lead circuit, no? The current through RC circuit here is going to lead. Not visible. IRC, both are there, no? Let me write IRC. This current should outlet and compared to applied voltage should lead, no? So that IRC I'm bringing here. Let me, okay, no, look at this. This is the, let it lead. Sir, on what basis you are drawing this? This is a phasor things. This the applied voltage zero phase. So let's assume that zero phase. So not given. I think best thing, sir, I'll assume some 30-degree phase. You assume this 30-degree phase, you'll die with mathematics here. So always assume some things where mathematics will get minimized. So usually it's a practice of nothing given, this to be zero phase. You can assume this having a phase angle 30 degree. If this having phase angle 30 degree, then Vs will come like this. Then IL will come here. Then this IRC will come here. Unnecessary mathematics will be inviting, no? So this is a reference for us. Let phase of voltage be zero. Okay, now we wanted impedance, no? So what is the, how we define impedance? Applied voltage by current. So let this be the total current I. We have here. So how you define impedance of circuit? Applied voltage Vs by I. I is what? RMS. All these are RMS only. Okay, let's calculate the total. First, this current I. Pure vector. It's a pure vector. So I want expression for I. So what is the expression for I? I will be IL square IR square plus 2IL IRC sine of 180 plus 5. Sorry, 90 plus 5. What is this symbol? Okay, we have this much here. Okay, let's further. What is I? 1 by 1. I is equal to Vs by Z. Square, no, it is vector. So Vs square by Z square. What is IL? IL should be Vs square by XL square. What is IRC? Vs square by R square plus X square minus. Okay, this anybody sin 90 plus phi? Cos phi. Sin 90 plus phi. Please reply. Sin of 90 plus phi. Huh? Sin phi, cos phi?
Cos phi, sir.
Cos phi, no? Yeah.
Root will not be there, sir.
Which one?
In the denominator, root will not be there, so you're squaring it.
Okay, okay, yeah. This is okay. This one 2. So what is IL? IL again Vs by XL. So IRC will be Vs. Now root. So this will be cos phi. So Vs square gets eliminated. 1 by Z square. Two cos phi. Let it be this one. I'll cos phi value will substitute. Cos phi, in anything can we write cos phi? Only separate phase angle will write it. This is R, XC, let this be phi. Cos phi, anything can we write R by cos phi will be R by root of R square plus XC square. Okay, let's see where we are ending up. So this will be 2R XC XL, XL it is. There should be independent of, okay, some mathematics.
But there minus it should be, sir.
Which one?
Then only will get.
Where negative sign? Somebody said sin 90 plus phi.
Cos phi only, sir.
Oh, sorry. Yeah, no. Angle, no. Vector addition.
Will get minus there.
Minus sin phi.
Minus sin phi. Huh?
Sir, then minus XC by root R square plus XC square, sir.
Okay, let it be this one. So cos 90 plus phi minus sin phi. I'll write it here. Oh, so many things will change. Huh? So what is the 2 sin phi? Keep it here. What is sin phi? Sin phi will be XC will come. negative sign. Check it now.
Yes, sir.
So here, yeah. So this will be so let's take 1 by r square plus xe square common. So 1 minus 2xe by L.
XL.
XL it will be.
It should be 0 now, sir.
This quantity should be 0. If this is 0, then Z will depend only on XL. So let me write here. Z to be independent of why Z to be independent of R? Because I want the current to be independent of R, that one. So current can be independent only when the impedance is independent of that one. For Z to be independent of R, Z or I. Z or I. Total current to be independent of R 1 minus 2 XLSC. This should be equal to 0. Or XL equal to so this will be omega L to omega C. Is asking the value of capacitance. So this will be C is equal to substituting this. We have to check options A and B.
The option will get
Which option?
E.
B option. So C will be 2 microfarad. Then what is the total impedance? I think total impedance Z is equal to XL only, no?
XL minus X.
I'm not getting. See, when this condition is satisfied, so here what will end up with? Z equal to only XL. And what is
Okay, sir.
value of XL? Huh? Therefore, Z should be equal to XL. Impedance of circuit. So this should be equal to 100 ohm. What is Z? Z is the impedance of not any branch of total circuit. Actually, if you check the advanced paper, no, only once they've asked parallel circuit. So only once, no, not many times, only once. But if you look at the exams, no, we do dump more parallel circuit questions, because in parallel circuits only open, we can ask you many best things are there. But if you look at the composition, the advanced, no, only once it has come. I think we should be a little bit alert. Like tomorrow weekend exams, I think Halir, you wrote weekend exam. We had more questions on parallel circuit than any other thing, because best questions are available in parallel circuit and only once they've asked in advance. So weekend exams and advanced exams, a little bit synchronization is not there here and there, I feel. So tomorrow, what shall I prepare? That's what you prepare. Also, few parallel circuits also. So whenever parallel circuit comes, it's about vector addition. That's what. See, like what is the basic idea? There's nothing to do big. You need not to learn anything big. Parallel circuit comes, you are going to take the vector addition of currents. Series circuits, if the elements are in series, vector addition of voltages. That's all, finish over. That's what I just took this problem to explain that particular thing only. Whenever parallel circuit comes, we are going to take the vector addition of the currents. You cannot just write I equal to IL plus IRC. What is actually I? The vector sum. Are you seeing this one? So what is the basic idea for parallel circuits? Finish or at least you remember this much. This will be in let him ask series, parallel, whatever let him ask. You can just take help of the vector addition, nothing to do. If you are good in complex number, you can take help of complex number because this is R is real number. XC will become imaginary. XL will become imaginary and do complex numbers, vector complex analysis. With that also you can find out very easily. That will be more lengthy. We do prefer to solve problem like this using vector addition only. What to do, sir? Like a more than two branches, then use vector like a unit vector addition.